Hey mathematicians, we have been studying all about different numbers and how we can find the factors of a number, multiples of a number. Today we are going to be learning about two different categories of numbers. Out of every single number, 0 to infinity, each number is either a prime number or a composite number. So as a fourth grader, if I ask you a question, if I say, is 7 a prime number or a composite number? You need to be able to tell me which one it is. So what does this mean, prime number versus composite number? Well, it's actually not too complicated. A prime number is a number that has only two factors. So think about when we were learning about factors and how usually there would be this long list of factors. A prime number is a special kind of number that only has two factors. So a composite is kind of the opposite. A composite number has more than two factors. So all those numbers that had that long list, those are composite numbers. So let's go through some examples and see if you can figure out what kind of number each one is. So let's go ahead and take this definition and move it up here in the corner so we still have it. Okay, so let's go through some examples. What if we have the number 7, like I mentioned? Well, we have to figure out how many factors are in the number 7, right? So we would make our little T-chart, and we'll start with 1. 1 times what equals 7? 1 times 7 equals 7. And then what else? Can I do 2 times anything to equal 7? 2, 4, no, not 2. Okay, what about 3? 3, 6, 9, nope, not 3. What about 4? 4, 8, nope. You know what? I think that there are actually only 1 and 7 that fit into the number 7. So if I were to write my list, it would look like this: 1, 7. That's it. Look back at your definition. A prime number has only two factors, and a composite number has more than two factors. How many factors does 7 have? Only 2. So I know that 7 is prime. Not too tricky. Okay, let's look at another example. Let's do the number 9. We'll do our little T-chart and we'll start with 1. 1 times 9 would equal 9. What about 2? Can I fit 2 into 9? 2, 4, 6, 8, no. Okay, what about 3? 3 times 3 will get me 9. What about 4, 5, 6? Nope, these are the only factors. So I can write them in order. 1, 3, I don't have to list the 3 twice. I can just say 1, 3, 9. So let's look at our definition. Does 9 have only two factors? No, it has 1, 2, 3 factors. So it has more than two factors. So that tells me that 9 is composite. That's it. So you just need to figure out how many factors are in a number, and then that will help you determine if the number is prime or composite. Let's just do a few more examples to make sure you understand. Okay, here we go. I put the definitions up top for you to help you remember. Let's get a little bit higher in our numbers and see if our numbers are prime or composite. Let's try 18. Start with 1. 1 times 18 is 18. 2 times 9. I can do 3 times 6. I'm going to extend this line a little bit. What about 4? Can I fit 4? 4, 8, 12, 16, 20. Nope, no 4. What about 5? 5, 10, 15, 20. Nope, no 5. And now I can see that I'm back at 6. So that means I'm done. And then I can make my list of factors. 1, 2, 3, 6, 9, 18. What kind of number is 18? Does it have 2 factors or more than 2? Well, more than 2, definitely. So 18 is composite. I'm going to write a C for composite. Okay, one more example. Let's say, what about 19? Make our T. 1 times 19. What about 2? Nope, 2's not going to fit. What about 3? 3, 6, 9, 12, 15, 8. No, no 3. What about 4, 5, 6? No, it's just 1 and 19. So how many factors does this number have? It has only 2 factors, so 19 is prime. I'll put a P for prime. That's it, mathematicians. You can do this.